In this video here, I'm going to be showing you how to find domain and range for any type of function, as well as looking at even and odd functions. So let's get started. With our warm-up here, we're going to be finding the domain and range for each of these functions. So what I like to start to do is just label what each function represents. So there are different types of parent functions, right? There's cubic, there's quadratic, there's square root, there is absolute value. So let's just give each one a name by its characteristic. Like this one here is x to the third power. Since the third power here is the highest power, this is definitely a cubic function. And whenever you have a cubic function, you have that shape where it kind of looks like a almost like an S in a way. When you have something that has the highest power, that's x squared, you got yourself a quadratic. So let's just label that as quadratic. And quadratic has the U shape, right, typically. And then you have an absolute value. Absolute value function is the shape of a V. And then you have a square root function because we have this root here, so we have a square root function, and square root functions look kind of like this, where it's like it is kind of like a shooting star is what I like to say, so it kind of goes on one way, like a sideways curve. All right, so now that we kind of got our brains warm here, let's take a look at that first one again. So it's a cubic function, and what I notice here, what I usually do when I'm looking at a function, let me write this up here. So when you typically have a function, just a generic template, is to look at the slope, or the number in front of x, to look at the shifts. So typically when it's inside of parentheses or inside of a root, you typically will have a horizontal shift. And what that means is if it's going negative, if this sign here is negative, it's pointing to the right. If it's positive, it's pointing to the left. And then this plus sign that's outside, so if you have a plus sign outside of the function, you have a vertical shift. See if I can fit this in. So a plus sign means up, a negative sign means down. And like I said before, the m here, the number in front of x, generally can be treated as the slope, but this part is really important. Whenever you use the slope, you always have the slope, the run is always 1. And I'll explain what I mean later, but typically we look at the number in front of x to figure out what the slope could be, so we can use that to help us find us more coordinate points. So let's get started using this one as an example and kind of practicing our shifts. So in this case, notice how there is a negative sign in front of the x. So I know that this here is a -1, right? So in this case, that number, the -1, is kind of treated as a slope. So the slope here is -1. But here's the thing. Slopes always have a rise over run. So you have to put that -1 over 1. So that's what I mean by putting the run as always 1. So the slope here was -1, but I put it over 1, because you always put the slope over 1. And so now what I do is with a cubic function, since this didn't have any left and right shifts, there was no plus sign or minus sign next to it. So it always starts at the origin. But because the slope is -1 over 1, I have to go down 1 over 1. And I'm going to curve down because that's what cubic functions do. It has a zigzag. So this side's going to curve down. Guess what? The other one's going to have to curve up. And so all I have to do is, instead of going down, I go up 1 over 1 and reflect. And I have my cubic function. And so now I have to figure out the domain. Notice how this curve stretches left and this stretches right. So it's going to, let me grab a different pen here. It's going from negative infinity to positive infinity. And it also is pointing down and up. So it's going to negative infinity and positive infinity. So in this case, the domain here is going to be all real numbers, since it's pointing infinitely to the left and infinitely to the right. So it's going to cover all the x values. And it's also pointing down infinitely and up infinitely. So I can say that the range is all real numbers as well. In fact, all cubic functions, domain and range, is all real numbers. Makes it easy. So anytime you have a cubic function, lucky for you, the domain and range is never restricted, so it's always all real numbers. Quadratics. So quadratics has this parabola look, and what you have to figure out is where to place the vertex. So in this case, notice how the slope here is also 1, right? Because the number in front of x squared is 1, so 1 over 1. But the vertex has been shifted, so it's going -4, which means, if we look here, this -4 is not in parentheses, it's outside of the parentheses in this case. So this is saying down 4. So instead of starting at the origin, you have to go down 4, plot, and then using the slope, this is 1 over 1, so up 1 over 1. And so you would just swing this around. Now, parabolas are nice because they just reflect across the y-axis. So all I have to do is go up 1 over 1 to the left to reflect. And there we go. We have our parabola. Now, parabolas also have a domain with all real numbers. The reason why is, notice a parabola stretches left and right with an arrow. So it's going to cover negative infinity and positive infinity on the x-axis. Whereas the range is restricted, because if you were to go down on this parabola, the lowest place that you can go is -4. You can't drop anywhere further than -4. But if you go up on this curve, it's pointing with an arrow, so it's going to positive infinity. So you're going from -4, the lowest number that you can go, to positive infinity, which is the highest number you can go. Now, infinities you can't touch, so we got to use a parentheses and a bracket on the -4, since it actually touches it at -4. All right, let's go on to C here. So C has an absolute value, and it's very similar to the quadratic. In this case, the inside here has been shifted to -2, which means that we have inside the parentheses is a negative, so that means right 2. So we are going right 2, and we also have a slope of 1, because that number in front of x is a 1. So in this case, 1 over 1. So if we're going right 2, instead of starting at the origin, we have to go right 2, which is this way. Plot. We're going to use our slope, so we're going to go up 1 over 1. And then we have one side of the v. To get the other side of the v, you reflect. So instead of going to the right, you're going to go up 1 over to the left. Plot. And there you have your absolute value function. Again, this is pointing left and right with an arrow, so you're going to be covering all of the x-axis from negative infinity to positive infinity. So this is all real numbers for the domain. The range is a little restricted because this v, the lowest part of this v is this minimum right here, which is hitting it at y equals 0. So 0 is the lowest part that this y can go, but it is pointing up with arrows, so it's going to be stretching to positive infinity. And we're going to put a bracket on the 0 because it does have a solid dot at y equals 0. All right, last one but not least, this is the square root function. So square root function does have a shift here. It's a +3. So +3 on the inside of the parentheses is a left shift. So we are going left 3. And it looks like we also have a slope of 1. So 1 over 1. So if you're starting at the origin and then you go left 3, you're right here. And this is a square root. So we're going to have to do a one-sided curve. So this says go up 1 over 1. So up 1 over 1 is right here. Plot. And curve it out. And do a sideways curve, or a shooting star is what I call it. And now when I look at this, it does have a few restrictions here, right? Like this part here is the furthest x value that it's going on to the left. So it's going from -3. Where my pen, -3, but it's pointing with an arrow. So that means it's going to positive infinity. So we're going from -3 to positive infinity. And I need a bracket on the -3 because it does touch it. As for the range, there's also some restrictions here, right? So the lowest y value that it can go is right here. This is the lowest part of the curve. And that y value is at 0 since it's on that x-axis. And now this curve is stretching upwards to the right. So if it's stretching upwards, it can go on to positive infinity because it has that arrow there. So it's going from 0 to positive infinity, and we're going to put a bracket on that 0 since it does hold it with a solid dot right there. And that's it. that is all of the typical parent functions that you see, and that is all of their domain and ranges. I know that was a lot, guys, but just hang in there. So now we're going to go touch base on our first definition that we are going to learn, which is even and odd functions. So even functions, let me just write out the definitions first. It is a function symmetric with respect to the y-axis. So if you were to graph this function, you can usually tell if something's an even function if it has a symmetry along the y-axis. But another mathematical way of telling if something is symmetrical is using this formula to check. And I'll show you how to use it. But basically it's saying that if you were to stick in an x value versus the same x value but only it's positive, they should give you the same output. That's what it's saying here. Whereas odd functions are a little bit different. So they also hold a type of symmetry, but it's not along the y-axis like the even functions. So it's with respect to the origin. And that's kind of a little bit hard to explain, so I'll show it through pictures. But the formula for this is basically if you were to stick in a negative x value here, you basically have the same output, only the output is negative. Okay, and I'll show you what I mean using example 1. So we have to tell whether these functions are even and odd. And I would like to do this without looking at the graph because some of you can figure it out by looking at the graph. So if I weren't to use the graph and just use these testers here, let me grab my highlighter. So these are what I'm going to use to test. So if I were to use this one here and test if it's even or odd, the first thing I'm going to do is look at the function. Notice how this function here is the positive version, right? So I need to figure out what's the negative version. So all I'm going to do is stick in negative x, and when I do that, I have my absolute value, but instead of x, it's going to be a negative x because that's what I inputted. Kind of like what we've learned in the last video or the last section. So if I were to input a negative x, absolute values take away the negative, right? So in this case, it will still end up being a positive x value when it comes out. So because these two are identical, grab my highlighter here, because these two are the same, we can say that this here is even. So they have to equal each other when you plug in an x that's positive versus the same x value, but it's negative. So this is even. Now let's try this one here. So this one's a cubic function, but again, this is the positive version. So I need to stick in the negative version and try to simplify it down. So that x to cube is going to be negative x cubed minus negative x. So all I did was, instead of this x, I stuck in a negative x. And instead of this x here, I stuck in a negative x. And I highly, highly recommend that you use parentheses when you do this. When you do any type of plugging in, I recommend parentheses, please. So in this case, if I were to take negative x and cube it, let's just think about it for a sec. If I take a negative x and cube it, that's like saying negative x times negative x times negative x. If I count how many negatives there are, those two will make a positive, but then you multiply another negative, it's going to make a negative x. And if you look at how many x's there are, there's 1, 2, 3. So this is going to be x to the third power, but it's going to be a negative x to the third power. Those two are two negatives, so when they're next to each other, they become a positive. And so now when I look at this equation here, I'm like, it almost looks like that, but this x cubed here versus this x cubed are opposite sign. And this x is negative and that x is positive. That's opposite from each other. So if I were to kind of rewrite this, so let me just take away this negative and this positive by undistributing. So if I take away this negative, I can rewrite this as x cubed minus x, because if I were to redistribute this x, this becomes a negative x, and distribute that x, that becomes a positive. So in that case, when I look at this here, that is the same as that. The only difference is this negative sign here. So this is the same equation, only this one's negative. So that means we have an odd equation. So we have an odd equation. By the way, you didn't have to show this step. If you got to this part and you notice that all the signs are flipped, then you can say that it's an odd function. All right, let's do a couple more so that way we know what we're doing here. And also I want to show you guys what if they're not odd or even. So let's go to C. So for C here, we have an x squared. So this is a quadratic. So again, they've already given her the positive, so we're going to plug in the negative version and use those parentheses. But if you square something, it always makes it positive again if the inside's negative, right? So in this case, this ends up being x squared, but positive, and a plus 1 here. So when you look at these two, it's like, aha, those are the same. So you have an even function, which makes sense because if you were to look at the graph of this function here, this is a quadratic, and it's been shifted up 1 because of that positive 1 right there. So this is what the graph would have looked like. And that's really funny because you can obviously see the symmetry that's happening on the y-axis, right? This half is the same as this half. So some people, they can just look at a graph and be like, oh yeah, I see symmetry there, it's even. But I highly recommend still doing this mathematical skill because not every single equation you can check the graph and be sure. So for D here, this one gets a little tricky, especially if you were looking on a graph. So again, we're going to use our mathematical test where we plug in a negative x. And this is x to the 5th power, and some of you guys are probably already getting a feel. Anytime this power is odd, this overall x is going to end up being negative. If you take negative x and multiply it 5 times, you're going to get back a negative number. So this is going to be negative x to the 5th power minus 1. And when I look at these two here, I want you to notice this x to the 5th and this x to the 5th are opposite signs, right? But the negative 1 and this negative 1 are not opposite signs. So first off, they are not even functions because they are not the same. So you have to eliminate out even. But unfortunately, they're not odd either because if this was a negative, then this needed to be a positive and it's not. So in this case, they are not opposite of each other. So you have to say neither. So that's why you have to check the signs of all of them to make sure. All right. And that is basically it for this video. So sorry if this video was a little bit long. The other video should be a little bit shorter.